Good afternoon. I'm George Hepworth with Grover Park Consulting. Today we're going to take a second look at our first PowerApps application we built to illustrate some of the concepts that MS Access developers need to understand to work successfully with PowerApps. We're going to take a second look at the PowerApps application we use to trick PowerApps into loading up to 10,000 records in a gallery. I'm going to take a look behind some of the things we looked at the other day, show you a way that speeds up that load time. One of the motivations for showing it to you in the way I did was that I wanted to drive home the point that even though it's possible to load many thousands of records, it's seldom a good idea. And we know that from our experience working with Access relational database applications, especially those connected to a remote data source like SQL Azure or SharePoint lists, where we were very cautious about loading more records into a form than we really need. So with that in mind, let's take a look. Okay, we're back into the designed environment for Microsoft PowerApps. I have started my Microsoft 365 account where I have the PowerApps development. Before I jump into the actual application, I thought it would be a good idea to mention this, which is the OnStart event that runs every time an application starts. It's the equivalent for Access developers. It's the equivalent of an auto-exec macro. It has certain events or steps that occur every time the application starts. I used it here to set some variables that I'm going to need throughout the application. This one, for example, I set a variable, to this string. Rather than type that whole string into the caption of every screen as I create it, I simply refer to the app title variable, and that brings along that entire string for me. Objects on PowerApps have a fill, which is the equivalent of the back color in the Access world, and a color, which is the equivalent of the fore color. I always have to stop and think, am I saying this correctly? Because fill is equal to the back color, color is equal to the fore color. So I set three variables, one to the fill of a screen itself, and then one for the fill of a label, and the other for the color of a label. I have these two defined, although I don't use them in this particular application. This is the last one that I recently added for this particular application. In the first video, I showed you a hard-coded value of 500 for the records that we're going to pull in. In order to make this slightly more flexible, instead of using a hard-coded value in the on-visible event of each of those screens, I set a variable called record limit to the number that I'm going to use in this application. So now if I change the number of records, I simply change it in one place. And each of the screens which loads and which repopulates a collection will use this for the record limit. Note that this is hard-coded here. I have not yet found a way to retrieve that property from the application itself. So it has to be set in two places, once for the setting for the application and once again here. Speaking of the settings, we'll go to the settings for the application. And here is where the data row limit is set. And you'll see now that it's set to 2000. It was set at 500 in the first installment. PowerApps will not let me exceed the 2000 limit, but it will let me go up to 2000 records or rows to retrieve from the server where delegation is not supported. And so this on my startup screen reflects that variable that was set. I'm going to rerun this just to make sure that everything is set correctly. Let's look at how this is populated. There's that variable and a string of text concatenated with the standard ampersand concatenate operator. That was a mouthful for me to say. If I change it in the onStart macro, it will reflect that change here and any place else throughout the application where I refer to it. That's the key thing. Let's play the application, starting with the startup screen. If I go to the app options, I can change this here. I won't do that now because then that would get out of sync with the actual app setting of the number of data rows that are going to be retrieved by default. But I could change it here if I wanted to test different values to see how they worked. We'll go back to the main menu. Note that at startup, the source table in SQL Azure now contains 9,427 records. I added a few in testing since the previous video. We'll start with the original screen, which is a collection of items in a gallery with a lookup field, and I'll explain the lookup field in a moment. Let's go ahead and click the button to move to the gallery, the screen with a gallery containing a lookup field. You'll notice we saw the same phenomenon we saw in the first video, where it starts with the fully populated collection and gallery. It's that line in the onVisible event which zeroes out or clears that collection and then restarts the building process to collect all of the items it needs to repopulate the gallery with the new collection. Notice that it has already put in our dates for the events and the ID numbers. These are the event IDs. But the sessions are not yet populated. That's because these are actually lookup fields. And just like in Access, when you have a continuous view form with lookup fields, it is slower to load all those lookups than it is to simply put straight data there. And the same thing is basically happening in this gallery. It's more pronounced because we are getting resource contention from the recording on top of the process of loading this collection, and it is much more apparent. When I generated this earlier today, it was going much more quickly. I was getting load times as low as 3, 4, 5 seconds. It took 9 seconds this time to load all of the records into this collection, but then you saw that it took several more. Well, that's still actually not completely done populating the gallery with all those lookups. And I think now we're at a point where all of those are up to date. I'll show you how I generate this. It's an approximate value for how long it took to retrieve the records originally into the collection. It doesn't reflect how long it takes to put those records into the gallery itself. With 2,000 records per iteration, we go through 5 passes, or 5 iterations, 5 recursions, to get all 10,000 records, 2,000 records at a time. And actually, as you can see, with 9,427, our final iteration is going to be through 9,429, which doesn't exist, but it gives us that extra allowance at the end to accommodate them. Let's look at some of the coding behind this. You should be familiar with the date diff expression. It's syntactically a little bit different from what we're used to seeing in the Access world, but it works the same way. We have a starting time and an ending time and the units of time that we're going to measure. How do we get there? We go to the visible, on-visible event of the screen. I do the same clearing of the helper collections. Then I set a variable called varStart, the value of now, and a variable called varEnd to the value of now. That allows the initial calculation of the elapsed time to be 0 rather than some odd number. After it's all completed, after the collection is regenerated and reloaded into the collection, we set varEnd to the current time using now, and that is fed back into the calculation to generate an approximate amount of time it took to repopulate that collection. Also in here, you'll see where we actually used that variable we created. The record limit is 2,000, and this calculation, I had to stop and make sure I was saying the right thing. This calculation reflects the fact that if we take the last record ID, subtract the first record ID from it, divide it by the record limit, we get an approximate number of 4.73, which we round up to 5 iterations. And then we do 2,000 records at a time in each iteration. We're still doing the kind of R-bar processing that can be quite slow. But we're doing this in 5 passes of 2,000 instead of, what was it, 19 passes of 500? And I believe it was visibly quicker, and by testing with this the time elapse calculation, I was able to verify that it is substantially, as much as 10 times faster in most cases to do it this way. So you can step back from the dire warning against loading thousands of records by expanding simply the number of records you're bringing back in each iteration. We're still looking at 9 seconds to load the records into the collection, plus several more seconds to populate the gallery. But it is much more doable. Let's look now at this lookup, which I mentioned is performing the same way you see a lookup field in an Access continuous view form. And the syntax is, again, very similar to what we're used to. We look at a session time of day table. This is a little lookup table with, I think, 7, 8 records in it. For some reason, I called that test time of day rather than session time of day because I was testing at the time I created it, and neglected to go back and clean up my my naming convention there, and it's kind of at the point where there's not a lot of value in that kind of cleanup. We bring back the test time of day, which is the equivalent of the session, and that goes into this field. Now, let's play the application again, and we're going to switch to a screen with a gallery which has no lookup. I'll start it, and then depending on how quickly it performs, I will probably pause the video and wait for it to finish, but let's look at it how it starts. Once again, it starts with the initial records and then zeroes them out as that line in the code hits clear event table, clear event collection, and then rebuilds it. Notice that it took approximately 8 seconds to rebuild the entire collection, and immediately our time of day IDs popped into the gallery along with the date of the event and the event ID. We're not having to perform those lookups against each of those time of day IDs to put something there, but we're still not completely populated in the entire gallery, and it'll take several more seconds to do that. So I will pause the video while that completes. And we're back with the gallery fully populated. And again, I'll just remind you that 8 seconds represents the amount of time it took to put the records into the collection. And then there was another 20, 30, 40 seconds to put all of the records into this gallery while you were gone. Okay, you'll notice now, of course, that instead of having the actual session type, we're looking only at the lookup, the time of day ID, which supports the lookup. And it is, once it's populated, both are fairly similar in performance. This one simply starts loading faster because it has less work to do. Now I'm going to show you one last thing here, which is how we go about adding new events. Step back and talk about that before I actually kick it off. We need to add our events to the underlying table. We can add events to a collection, just as we went through this process of iteratively adding them in 2,000 record chunks. We could add them one at a time by adding a new record. However, that would not end up in the underlying event table. So when we add the new record, our first step is going to be put the new record in the table in SQL Azure. Then, in order to reflect that new record, we repopulate the collection. There's a penalty with redoing that, but it does bring the total record count back in sync. There's pluses and minuses to both. If you're working with an application where real-time syncing of the records is not necessary, you could forego that step of rebuilding the collection after adding a new record. I can't think of too many situations, though, where you would want to have that happen. It would be either adding new records and your filtering would be looking at a very small subset, and we wouldn't be dealing with all this thousands of records in a collection. Or you would be looking at a static collection for some sort of summary reporting process. So it would generally be either or. Here we're trying to combine the two, and that results in slower performance. I'm actually going to pause the video now, switch back to the lookup-based gallery, and run the process of adding a new record. And we're back again. This time it took approximately 6 seconds to retrieve the records into the collection, and then again, somewhat longer to repopulate those records into the gallery and complete the lookups to populate all of the sessions within each event. Now, I'm going to add a record. I'll do that first to illustrate the process. When I click the plus sign, it will add the record into the underlying event table and then regenerate the collection and repopulate the gallery with that new record. Watch for it. We're seeing the little ants running across the top of the screen, and now the new record is in the events table and we're repopulating the collection. And again, to avoid boring your socks off, I'm going to pause until it's finished. I brought you back a little early. We're on the final pass. You can see that we now have 9,428 records, one more than we had before. It took 83 seconds to rebuild that collection, or to repopulate that collection. This does not reflect the time it takes to put the records into the gallery. Why that happens is that the event table itself has been changed, and so it has to refresh against that whole new record set. And as a brand new retrieval, it's going to take. This time is very comparable to what I was seeing with the 500 record limits. I'm going to take a big chance and resort this and see if we can see that new record. So there's the newest record right there. Well, actually, that's not the newest record. That's not, should be 9428. Right there is the newest record. And again, these are being generated randomly, so don't pay any attention to this sequence here, and I'll show you how that happens next. Did quite a bit of testing today. Let's stop the application and go back and look at the design. Okay, so we're back. We've got control back. I've selected the icon that adds new records, and now we'll look at the code behind it. Expand this so we can see it. And again, I'm setting two variables, the start and the end time, so I can calculate approximately how long it takes to do it. This section is the section that adds a new record. I used the patch command to do that. Now, again, remember, we want to put the records into the underlying table. So here, the reference is to that table, not to the collection. You can use this same method to put new records into a collection. But if you want to make them permanent, and again, reminder, a collection is a temporary in-memory table of items. To be persisted, it has to go into the underlying table in the database. So we're going to patch, and patch is a command that adds records or updates records in an underlying data source. Since this is a new record, we're just going to accept all of the defaults of a new record in that table. We're adding two fields and only two fields. We're adding the event date and the test time of day. This syntax refers to the exact name of the field in the table. This has to be exactly the same as the name of the field PowerApps will encounter when it tries to add that record. If you don't get this exactly right, it will fail. And again, even though I failed to update my naming convention, I'm not going to change it now, but but that requires that I then use that exact name that's found there. I use today's date for the event date, and then I generate a random number between 11 and 16. And the values of the sessions in that session table have session IDs of 11 through 16. So I just, rather than try to add one through the interface, which would just take up a little extra time, I randomly generate one and add it. When that's done, we drop back into our collection section. Clear out the helper collections, clear the main event collection, start through the process of generating first and last records, finding out how many iterations we have to do by looking at the 2,000 record limit. Again, this would be set at startup, so you could change that if you wanted to. We figure out how many iterations we need, and we have 5, and that's based on this math, which takes the last minus the first, divides by the record limit, and that gives you a number which is going to be something like 4.7 or 4.8 or something, which we round up to 5. The rest of it we looked at the other day, and if you want to review this, you can go back to the first installment of this video on large record sets and collections. The last step is to collect all of those records in the table, including the one we just added, into our events collection, and then set the variable for the end to get the elapsed time. We're still seeing contention because we've got both the recording and this application with huge numbers of records working, and that sometimes bogs me down. So I'm going to pause again till we get control back. So we've now seen 2 variations on this process, one with a very small number of records in each iteration, 500, and one with the maximum number of records that we're allowed to bring in through this process in each iteration. We saw comparative times when we generate a new collection after adding a record, but once we have the records intact, or stable, I should say, in the underlying table, then each subsequent retrieval becomes a little bit quicker, or in some cases up to 10 times quicker, so I shouldn't say a little quicker. That pretty much covers everything I wanted to show you in this aspect of using PowerApps with existing relational database data sets. As I move forward into other videos demonstrating other processes, I will no longer invest a lot of time in loading large record sets, because obviously that slows things down tremendously, and depending on what else is going on, up to 10 times as slow. In the next installment, I will show you an alternative way to limit the number of records you bring in. So we're going from bringing in everything to bringing back only a small subset of the records that we actually need to use in our PowerApps applications. I hope you liked what you saw here today. If you do, please hit the like button and subscribe to my channel. See you next time.